Hi, my name is Vidya Neerkundar. EDA tools that work on discrete functions is typical on how the tools operate, but Tessent platform integrates the tools together and creates an RTL-based hierarchical flow that can be used in implementation of design for test DFT solutions. In this video, I will show Tessent capabilities that are available as reference flows and test cases. This video is one of the series of Vidya's DFT architectural tips that will assist in different aspects that aid in DFT. DFT insertion for a chip with many hierarchical physical regions may be challenging by itself. Tessent products offer an integrated solution to test components on a chip. Every design has lots of memories that need to be tested with memory best. Some form of repair scheme is used to improve yield. Sometimes, on cutting edge technologies, new algorithms need to be programmed to test the memory best post silicon. Analog or mixed signal, if present in the design, may need to be fault graded to see how much coverage is achieved by testing these components. Logic bits may be used to test logic in the chip for in-system test requirements. The logic bit needs to be run for power on self-test, CPU access, etc. Mission mode is used if the BIST, either memory BIST or logic BIST, needs to be run in system, and this provides the access mechanism. Pad IO macros may need to be inserted with boundary scan. Boundary scan compliant tests for 1149.1, 1149.6 AC JTAG, contact IO, or leakage tests could be generated with Tessent. Tessent iJTAG may be used to connect instruments to the iJTAG network, verify and validate it. Instruments are anything that may need to be controlled like an IP. ATPG pattern generation for logic in the design can be done without compression or with compression using test compress. The compression is also used for hierarchical ATPG, which is key for pattern retargeting and merging. To generate patterns, need scan chains to be stitched and inserted in order to perform hierarchical ATPG. Wrapper analysis is essential. Test points can be used for reducing pattern count for ATPG. On-chip clock controller is used for clock selection, clock chopping, and clock gating during pattern generation. It would be great if there are test cases that show how all these Tessent products integrate together. This is exactly what is shipped along with Tessent software. Under the software installation tree, share usage examples directory, the test cases are located. The Tessent example hierarchical flow test case show how DFT can be inserted into an RTL design once for the entire chip if layout of the chip is done once. The Tessent example hierarchical flow test case show how DFT can be implemented hierarchically and also includes hierarchical ATPG, pattern retargeting, and merging. The Tessent example hybrid TK-LBIS flow test case shows how to implement hybrid test compress and logic best. Tessent Shell User Guide has lots of reference materials. There is architectural guidelines for hierarchical designs. There are reference flows that describe in the Tessent Shell User Guide for the flat and hierarchical flows, including hybrid TK-LBIS flows. Also, there are other examples and solutions described in a separate chapter. Thank you for watching this video that describes references to test cases on how DFT can be inserted on RTL or gate level designs. There are more videos on Vidya's DFT architectural tips that guide you to assist in DFT implementation. Those videos cover a variety of topics like testing asynchronous resets, use of boundary scan chain in ATPG, use of on-chip clock controllers, etc., just to name a few. Thank you.